Hello, welcome to this video on transformations. We're doing something a little weird today, so we're gonna learn transformations via the MonkeyCat. And the MonkeyCat is essentially this little drawing that my mentor taught me my very first year of teaching. It's a monkey combined with a cat. And essentially, it's just a way to make this a little bit more interesting than just me drawing parentheses, right, or just the square root, right? So essentially, the monkey cat makes it fun. The legs of the monkey cat essentially represent a square root or parentheses, right? So it's very important what we are actually changing about the function. Are we changing something outside? Or are we changing something inside, right? Inside of the legs or outside? So it just helps me remember this stuff a little bit easier. Hopefully y'all too. If you think this is super lame, right, you can just do parentheses, right, or square root or something like that. Anyway, the kinds of transformations we can do, you might want to have 6 or 8 templates. Ooh, I have a lot of these. So it looks like I have 10 here. You can get away with doing maybe 6 if you just put plus minus in the same picture. I'm going to do them one by one. So we got transformations that can happen outside of the monkey cat. So we have things like we can add 3, right? So this would be up by 3 units, right? A translation is what we call this. Translation. Right? So if you were to have the graph of x squared and you add a 3 to it, it would just take that U shape, move it up. Right? Simple. If we were to subtract by 2, we move down by 2. Again, another translation, right? But just different direction. Translation just means shift. All right, so we have a parabola. If we subtract that 2, it moves it down 2 units. We can also do, obviously, not just addition, subtraction, we can multiply. Right, so if I have, let's say, times 3. So the key part here is that 3, our number, is greater than 1. It's super important to point out here. This creates what we call a vertical stretch. All right, so we're going to take the graph and basically stretch it up and down. So the way this kind of looks is that you have a narrowing effect. Right, so if I were to draw another parabola, essentially anything that's not touching the x-axis is the y value is going to be multiplied by 3. So the higher they are, the farther they go. Right? And so you get like a very narrow parabola after the stretch. Right? So it's a vertical stretch. We can also multiply by numbers that are less than 1. Right? So the fact that this 1/2 is less than 1 tells me I'm going to have a vertical compression. Right, so this graph is going to be squeezed. So if I, again, go back to my parabola example, this parabola is going to be squished. All these points are going to go down towards the x-axis. Right, and you're going to get something that seems to be a little wider. Right, so there's a widening effect here. And there's one more. My bad. If we have a negative multiplied to the outside, right, technically we're doing times -1. So notice how we did bigger than 1, smaller than 1, and now we have this -1 factor, right? This is going to create a vertical reflection, or you could just say a reflection over the x-axis. You could say that as well. So that again, if I go back to my parabola example, parabola, it just flips over. It doesn't stretch or compress, it just flips over that axis, right? And these are all of the vertical transformations. Vertical translations, up and down, vertical stretch, vertical compression, right? You're squeezing it, and then vertical reflection. Okay, hopefully y'all have seen this before, so I'm going fairly fast here. Feel free to pause it, rewind, slow down. Inside of the function, so what happens if I add, let's say +5, right? And you got to be careful here because your instinct might be to say that the graph is going to move to the right. It's actually not, right? This is going to be a translation to the left by 5. And that's a really strange thing to think about. So what's kind of confusing is that when you guys learn the coordinate system, the positive end is to the right and the negative end is to the left. The problem is that's not really what this is doing. So if you were to graph x squared, and you can do this on Desmos, you can check this yourself, right? And you were to graph, this, so this is x squared, the parent function. If we were to graph x plus 5 squared, it actually shows up over here. Whoops. Shows up to the left. And you can check this yourself, right? It actually shows, it moves the graph to the left. I don't have time to prove it. I don't want to, that would take a fairly decent amount of time. I'd rather get to some practice after going through this fairly quickly. But yes, it does the opposite of what you might think. So like if we were to subtract 1, this would be a translation to the right by 1. All right, so parabola, it just shifts over by 1 unit, like that. Okay, we can also do multiplication on the inside. So if we want a narrowing effect, right, we're talking about horizontal motion here. So if you want your graph to narrow, one way to do that is to stretch it vertically, but another way is to compress it horizontally. You could squish it from the left and right sides like an accordion, right? So how do we do that horizontally? Well, the compressions happen when you multiply by a number bigger than 1, right? So like something like 7. 7's bigger than 1. This will give you a horizontal compression. Horizontal compression. So that basically we will have something like this occur, right? All these points sort of get squeezed towards the y-axis, right? And if we multiply by a number smaller than 1, let's say 1/3, this is going to give me my horizontal stretch. Again, I know this seems backwards here, right? So yeah, because 1/3 is smaller than 1, we get a horizontal stretch. So the graph is going to widen. All right, so I've got my parabola here. It's going to stretch out and widen out. And, if you get it really detailed about it, you know exactly how wide it's going to get. It'll be by a factor of 3, which, funny enough, is the denominator of that fraction, right? That's not coincidence. And last one, put a negative in there. This creates a reflection over the y-axis. Right. Now, for a parabola, you can't actually see that, right? If I were to take a U-shape and flip it over on both sides, it actually stays the same. So in order to see this kind of transformation, it would actually be better to use like the square root of x, right? You can actually see that. Because then it's very clear, right? It's going to flip over and create this red graph. So this would be the graph of square root negative x. It's going to flip over. Okay, let's see if we can knock out a few practice problems and get y'all started on this translation worksheet, which I'll have copies sitting on my desk at the front of the classroom. Unfortunately, for Block 8, had an appointment to go to. I couldn't make it for you guys. But this video will be helpful to everybody in case you forget all this stuff. So we've got a quadratic. We've got a nasty little fraction there. Maybe I might have to do that. We'll see. I've got an absolute value, a square root, another quadratic, absolute value, a square root. Okay, so 2 of each type. Maybe I just do 1 of each, right? And I'll try to do maybe the trickier ones. Let's see, maybe I do, let's start off with this absolute value. Let's just fill in some of the details. Let's do green, right? So the parent function, that's that absolute value function we learned last time. This minus 1 gives us that vertical shift down by 1. Do we have a reflection across the x-axis? No, right? We don't have a negative there in front of that 2, so we're good there. Horizontal shift, that's that negative 2. It's going to cause this, right? We're going to move to the right by 2. And if you forget all this stuff, just go back, reference all of our MonkeyCat examples, right? Y-intercept. Best way to find y-intercept would just be to use the function f of x and plug in 0 for x. That's how you always find y-intercepts. So we get 2 absolute value, 0 minus 2, absolute value, minus 1. So we get 2 times absolute value, negative 2, minus 1. Remember, absolute value makes it positive, so we get this. 4 minus 1 is 3. So my y-intercept is going to be 0, 3. And we should absolutely, no pun intended, put that point down right here. Cool. Domain. Absolute value has all real numbers in its domain. Doesn't matter what transformations you do to it, right? Shape. Is this function going to widen, narrow, or neither? Well, if you go back to our examples, right, we're kind of in this situation right here because we have a number bigger than 1 outside of the MonkeyCat. So we're going to narrow, right? The function should get a little narrower than what it typically looks like. Remember, you know what the parent function looks like. You have that parent function worksheet. Let's worry about the range later. So the point is, this parent function, if you remember what it looks like, is a V shape. Right? So something like this. So we kind of know what's going to happen, right? It's essentially going to move to the right by 2. It's going to move down by 1. And it's sort of going to stretch vertically, right? So it's going to have a steeper slope. In fact, if the original function had a slope of 1 for this line, the new function should have a slope of 2, right? So we can already, if you're thinking ahead, you can actually probably sketch this almost immediately. But if you don't quite see it, worst case scenario, you just plug in some numbers. So I have some empty space down here. And usually it's a good idea, especially when you're trying to find like this point here or the vertex, is to plug in something that makes this part equal to 0. That's going to work for parabolas, square roots, and absolute values. So let's plug in 2. Something got in my throat here. Okay. F of 2 equals 2 absolute value, 2 minus 2 absolute value, minus 1. And we get a big old 0 for that first term, right? This whole thing becomes 0 minus 1. Don't forget the minus 1. And so When I plug in 2, I get -1. So 2 comma -1 right there. And it might be a good idea to go ahead and plug in 1 for this tick mark, and then 3 for this one to see where those points are. And I think we'll be able to see the whole graph at that point. So let's plug in 1, 2, absolute value 1 minus 2, minus 1. That gives us 2, absolute value of -1, minus 1. That becomes 2 times 1 minus 1, and that becomes 2 minus 1. And we get a final answer of 1. So the point that should be on my graph is 1 comma 1, which would be right here. I bet you we're going to get the same sort of thing when I plug in 3. So 2, absolute value 3 minus 2, minus 1. We get 2 times the absolute value of +1, minus 1. So notice these two expressions are going to calculate to the same number. They're both going to turn into 1. So we can kind of see the symmetry now. There's basically going to be this like line of symmetry right here, because if you go to the left of it or to the right, you sort of get the same y values. And we know it's going to be some kind of V shape, right? So it should have that symmetry. So at this point, we can just fill it in, right? So there's one part of the V, there's another. Obviously, if you have notability, they make it straight for you. And notice our slope, right? Up by 2, over by 1. So that's exactly what we thought was going to happen, right? It's because of this 2 right here. Cool. And now we can answer the range. The range, we go from this is the lowest the function goes, and then it just keeps going up forever, right? So that range is from -1 to infinity. Remember, you always put parentheses on infinity. In this case, we include the -1 because this point is filled in, right? It's not a hole. We're not getting super close to it, but not touching it. We are getting there. So that's a pretty good example. Okay, let's try to knock out 2 more. 3 looks a little challenging. We can do it, though. I just want to look at everything else. Yeah, so I think I'll do the harder of the square root ones. I feel like if you understand this one, you can certainly do the other. And then I'll probably just go back and do number 1. Yeah, in fact, maybe I should do number 1 because, the square root, maybe this will be good prep for the square root one. Okay, so parent function, right? That comes from basically like this squaring part. That's telling us we're dealing with something like x squared or like a parabola. So expect to see some kind of U shape. Do we have a reflection? Well, we don't have a negative here or in front of that x, so no reflection. Do we have a widening, a narrowing, or neither? Well, so this number is bigger than 1. If you go back to your MonkeyCats, you'll know we're going to narrow, right? A narrowing effect. Domain. Think of the domain of the parent. Should be basically the same in most cases as your new function, right? So like in this case, it's fairly easy. We just say all real numbers, we are allowed to plug in any number into this formula, and there are no issues, no division, and no negatives in square roots. So that's good. Vertical shift. Yeah, so this -4 is going to tell us we moved down by 4. And then we have a horizontal shift from this +3. Remember, that's going to move us left by 3, not to the right, even though you might be thinking that. It's to the left. Y-intercept. Again, use the function to find the y-intercept. Right, so I'm going to calculate f of 0. What is f of 0? It's going to be 4/3, whoops, 4/3, parentheses, 0 plus 3 squared minus 4. So we get 4/3, 3 squared minus 4. Make sure you're actually following PEMDAS. I saw some people on the quiz were doing this multiplication first and then the power. In PEMDAS, exponents happen first, guys. So the way this happens is 4/3 times 9. Then we do the subtraction at the end. So 4/3 times 9, it's going to give me 12. And don't forget the minus 4 gives us 8. So our y-intercept, we plugged in 0, input of 0, we got an output of 8. So that's going to be 5, 6, 7, 6, 7, 8. So right here. Again, let's hold off for the range. Let's try to find some more points here. And again, let's focus on finding the vertex of this thing first. So ask yourself, what could I plug in to make this equal to 0? I'm going to plug in -3. It's usually going to be a very easy point to find. So 4/3, x plus 3 minus 4. So I'm going to calculate f of -3. 4/3, -3 plus 3 squared minus 4. And if you do that, you get 0 minus 4, which gives you minus 4, right? In fact, really, if you see those translations, they usually tell you the coordinates of the vertex. You could memorize that if you wanted to. But sometimes people make simple mistakes like they say, oh, the vertex is at 3, -4. That's actually not correct, right? The vertex is at -3, -4, right? So simple mistake that a lot of people make. They try to take shortcuts. So -3, -4 would be way down here. That's my vertex. Usually once you find that, you want to go 1 unit to the right and 1 unit to the left to find some other points. Right, so notice how high our parabola goes. So I'm going to plug in -2 now. Wait, is this the right? No, that's the next problem. Yeah, so f of -2 is 4/3 -2 plus 3 squared minus 4. So we get 4/3 times 1 squared minus 4. That becomes 4/3 minus 4. Okay, so 4, you gotta get a common denominator here. We get 4/3 minus 12/3. Okay, so that leaves us with -8/3. Yuck. What a gross number. Okay, if we actually try to divide this out, we get -2.66 repeating, right? So that at least tells us kind of where to put the point. So I'm going to do my best here. -2 comma -2.6 repeating. So maybe right about there. -2.66 repeating. That's probably close enough, right? Now you might be looking ahead and saying, well, I think I kind of get the sense, if this is the vertex, right, then we kind of already know there's another point hiding over here, right, with the same y value. And you're right, that's true. So really, if we can maybe find one more point, maybe at an x value of 1, we can get a really nice shape for this sketch. Right, so let's plug in -1. 4/3 -1 plus 3 squared minus 4. 4/3, 2 squared minus 4. Okay, that's going to be 2 squared is 4. 4 times 4 is 16/3. Minus, we already know, minus 4 is 12/3. So 16/3 minus 12/3. That gives us, gives us 4/3, or about 1.333 repeating, right? So -1, comma, positive 1.3 repeating. So 1.3 would be around here, right? So this is the point we just found. And of course, right, if you know this point, you also know it shows up over here. And we have our vertex, our y-intercept of 0, 8. That will also show up over here. And now this will give us a gorgeous, beautiful parabola. Just amazing. Look at that. The more points you have, the better you can sort of get that curve right. Check that out. Awesome. Okay, I know you guys don't feel that way about mathematical curves like I do, but sheesh, that's a good one. All right, number 3, parent function. I'll try to go through this somewhat quickly. I know this video is getting long. Reflection across the x-axis. This negative tells us yes, right? So keep in mind the typical parent function looks like this, but we know it's going to flip at some point, right? And it's going to be upside down. So keep that in mind. Is it going to widen, narrow, or neither? So this 3/4 tells us we got a vertical compression going on. That's going to give a widening effect, right? So just as another transformation, it'll be upside down and it's going to kind of stretch out kind of like that. Okay? Just trying to visualize this stuff here. That's why I draw all these pictures, so I can see kind of what the answer is supposed to be. Domain. What are we not allowed to plug in to this thing? Well, -1 is okay. We just can't go any lower than that. Right, so our domain, hopefully you'll see, is -1 to infinity. All those numbers are totally fine. Right, we can plug in any of those. Vertical shift, that's that +3 there, right? So we're going up by 3. Horizontal shift, that's that +1. That's going to move us, not right, left by 1. And then we have a y-intercept, which should be pretty easy to find here. Let's just plug in 0. Right, so f of 0. Oh, sorry, we're using h. H is the name of this function. H of 0. Now, you guys might think it's funny that I take such meticulous notes like this about exactly what I'm doing, plugging in. I guarantee you when you get to calculus, the problems get so long that you have to organize your work like this. Otherwise, you get totally lost. Completely. So I don't want that to happen to y'all. Okay, so we have square root of 1 is 1. So we're just left with -3/4 plus 3. That's -3/4 plus 12/4. And that gives us 9/4. All right, so our y-intercept is 0, 9/4. So 9/4, if you try to do some quick arithmetic in your head, it's about 2.25. Actually, it's exactly equal to 2.25, which is good. Good for us. And that should be around here, right? 0, 2.25. So that's a point. That's nice. Let's find some other ones. Now with the square root, right, you don't want to just plug in whatever number that first comes to your head. Plug in a number that's going to help you here, right? Like if we plug in 0, that's going to work really nicely, right? Because then we'll get square root of 1 here. We also, another nice number to plug in might be 3. 1 plus 3 is 4. That's a perfect square. 8 should be good, right? So I would do those. I wouldn't try really anything else. Of course, -1 would be a good one. Actually, we already plugged in 0, so I take that one back. We already did it. So let's try these other three, right? So -1, h of -1. -3/4 square root -1 plus 1, and we had plus 3. Okay, so we get 0 plus 3, which is 3. That's a really nice point to know. In fact, you know what this is? That point right there corresponds to the point at where the point from the origin went, right? So this is basically the left end of my domain here, right? We already said the domain starts at -1 and it goes to the right. So we know the graph does not exist left of that point, which is really good. Let's plug in, what did we say, 3? Yeah, let's plug in 3. H of 3. So we get -3/4 square root of 3 plus 1 plus 3 on the outside. So that's -3/4 times the square root of 4. Now you have to calculate the square root before multiplying this thing. That's just PEMDAS, right? P, parentheses, also works for square roots. Square roots count as parentheses. So square root of 4 is 2, and then we get this plus 3. So we get -3/2 plus 3. Okay, so this is -3/2 plus 6 over 2, and that gives us 3 over 2. All right, so we plugged in 3, we got 3. Sorry, did we get -3 over 2? I guess we got positive 3 over 2. Oh, 3 over 2 is 1.5. Yeah, so that makes sense. 3, 1.5, right about here. 3, 1.5. I typically don't like decimals, but they're going to help us sketch these points. Let's try 8. Let's just see what happens here. We might have enough to sketch it by this point, but I'm going to go ahead and do this one anyway. All right, -3/4 times the square root of 9 plus 3. So that's -3/4 times 3 plus 3. Okay, so we get -9/4. Let's go ahead and convert that. So 3 is the same as 12/4. Now we add them together and we get positive 3/4. So I plugged in 8 and I got, it's a lot of work here, but I got this output. And yes, I do expect you guys to actually be doing stuff like this. Many of your quizzes and tests will be no calculator, right? Now, you won't always see something this crazy. In fact, I try to avoid fractions whenever I can, so that way when y'all do plug in stuff, you don't have to run into them as well, right? This is just one of the harder examples. I wanted to do a hard example just to show you all this makes sense. It's logical. You can be confident about it. So 8, 3/4, which is 0.75. So that's going to be, boom, 8, 0.75. And with that, we get this nice, super beautiful, upside down, stretched out square root curve. And that's it. And what's great about transformations, guys, is you can make up your own problems, sketch them out yourself, and then just graph it and see if you did it correctly, right? You could make up hundreds of these problems and just check them instantly. So anyway, I hope this was helpful. So we've actually already done, what is this? Like, this is half of the transformation homework, right? I told you guys in class the other day, I'm going to push those due dates to Sunday. Don't try to rush them. Take your time. Make sure you actually understand what you're doing here. Because obviously, whatever next quiz we have, sometime next week, will have transformations on it. So all you have are 3 more. And luckily for you guys, I did the ones with the fractions. I mean, there is a 1/2 here, but there's only 2 transformations going on, this one and this one. So in that case, it's a little simpler than what I showed you guys. So anyway, good luck. Come by my office if you need help. And remember the monkey cat. All right, stay frosty, my friends.